In this short demo, we'll take a look at the Abemis.com image scanning software, GUI, and then we'll perform a simple 4x4 scan to get an idea of how this all works. So let's get started with the GUI. So the GUI has a set of controls on the left, your image is on the right, and right now we're looking at a cross-section of a spinal column of a rat, and it's about 3x3 millimeters or 4x4 millimeters. And we're viewing this right now in 4x objective. And we can manually move around just by moving the microscope. We can turn on the motors and turn them off and move things around in various fashions. And here's our autofocus and 3D mosaic capabilities in our mosaicing system. And you can also perform a simple Z scan where it just scans through the Z axis of the specimen. Before we do any imaging, we want to perform a white balance and a snap calibration to provide a flat field. We want to eliminate some of these shadowy sort of vignetting effect that you get from any microscope, and we flatten the image. So the first thing to do is to take a look at the image in 10x. So I'm going to rotate the objectives, and we'll position to 10x, which means we have to refocus. You can very quickly, easily manually refocus. There we go. And now you can see we're viewing the same object at 10x, which means we're going to need a larger scale image, obviously. So let's do a white balance first. You can see this is kind of blue, so I'm going to move off of the slide into a region that's basically neutral, about here, and I'll perform a white balance. And now you see it's now all neutral gray. And we'll perform a snap calibration, which will remove any of this vignetting effect. Okay, so now we have a white field, flat field. It's perfectly flat. And let's move manually down to the section region again. And I'll starting position at the upper left corner of the specimen. And we'll perform let's perform a 4x4 scan of the specimen. First, we'll go ahead and autofocus. We'll perform a quick autofocus, and what it does is it uses an edge detection algorithm, and the more edges, the more focus. So that's how it works. And it works very well, actually. So now our motors are all set on. I'm going to move the motor down and up. Let's switch to 10x objective. Can't forget that. And now we're at the upper left corner. That looks pretty good. And we will start a very fast scan. Actually, the motors are all energized and running, so we'll go ahead and set the home position. That way everything's zeroed out. And what it does is a quick jogging in order to pre-tension the belts in the directions of scanning motion. So starting from here, I also want to mention that we can perform all kinds of different exposure compensation, brightness, contrast, and of course, since you have access to the source code, you can add or change any kind of imaging control that you want. So I think that's an exciting feature of our system. Right now we're at maximum camera resolution, and we will be saving this as, we'll call it spine test. So you put your root file name in here, and it'll automatically add the Z, X, and Y row column notations to the end of the file name. And you can't, there's an option to save as TIFF. Right now I'll save it as a JPEG because it saves a lot of disk space. So, all right, I think we're ready to go with a quick scan. So 10x, let's perform a 4x4 scan. Might not be enough. We might not capture the entire specimen. I could use autofocus and 3D mosaicing, but for now, for interest of speed, I'll just go ahead with the straight mosaic. And once again, it does the jog, the initial jog to retension of the belts. And now it's going to move quickly through the scan. Probably could have done a 5x5. And we'll move to the next row and scan again. All of these offsets for the scan are pre-programmed in a text file that gets loaded into the to the code program. It's loaded in just prior to the actual scanning procedure, so you can change it on the fly. It's kind of another neat feature. We can change all the mosaic and characteristics on the fly, and it's done. So very fast. And let's take a look at where the files are stored. Right now, by default, they're just stored in the root directory of the of of the program, which is located here. Testflight 2, I've placed it here in this folder. And we can take a look at the images very briefly using XNView, which I like this program. And we can see that, oh, okay, it looks like everything's pretty lined up. There might be a little too much overlap here. We can adjust that on the fly. But this will make a perfectly good reconstructed image of this spine structure. Okay, and that's about it for the demonstration right now. Maybe I'll stitch this together and show it in a minute as it's all in one large giant gigabyte image. Okay, so I've gone ahead and used image J to stitch the individual tiles together, and here's the result. It's pretty fantastic. So this is at 10x objective, and you can really see incredible detail of the entire structure in this image. That's 100% right there. Now we're at 70%. And let's just go back to the full screen. And yeah, it's pretty exciting. So that's it for the demo, and thank you for watching.